Okay, good morning. Section 4.2, binomial probabilities. And I'm going to take a minute to show you some tricks in Google Sheets. Let's take a quick look here we're going to work on this example number 3. Now, binomial probabilities are probabilities where there are only two outcomes, okay? Those two outcomes are a success and everything else is failure. And lots of things can be defined as binomial probabilities because all it takes really is to define that only one particular outcome is considered successful and all other outcomes are considered failures. And something that has lots of outcomes becomes a binomial probability when you're looking for a specific outcome. Very important to know this definition. Experiment is repeated for a fixed number of trials. Each trial is independent of the others. There are only two possible outcomes for each trial, success and failure. Probability of success remains the same for each trial, so you can't be flipping a coin and rolling a die because it changes. The probability of success would be different for each trial. And the random variable, in this case, counts the number of successful trials. We want to know how many successes occur. Notation for binomial experiments, n is the number of trials that will occur. Lowercase p is the probability of success of each trial. Lowercase q is the probability of failure of each trial. And x is the random variable which represents how many successful trials occurred. Okay, so we'll go through, jump ahead here to example number 3, and we'll talk about this. In a survey, workers in the United States were asked to name their expected sources of retirement income. The results are shown in the graph. 7 workers participated in the survey are randomly selected and asked whether they'll rely on Social Security for retirement income. So some important information is given to you there. The first one is 7 workers are being asked. So that indicates that we are going to have 7 trials. And we'll mark that in our Google Sheet, n equals 7. So there we go. So next we want to look for our other values here. So we're talking about how many are going to rely on Social Security, and if we go ahead and look in here at Social Security, we will see that 28% are going to rely on Social Security for retirement income. That's going to be our probability of success. You randomly walk up to one person and ask them, what are you going to rely on for retirement income? There's a 28% likelihood that they are going to say Social Security. P equals, and we're going to put in 0.28 as our value. Probability of failure, then, P and Q have to add up to 1 or 100% because there's only two possibilities here. Either they say retirement income is Social Security, or they don't, or they say anything else. So Q, probability of failure, is going to have to be 1 minus 0.28 or 0.72. Those two numbers always have to add up to 1 or 100%. Create a binomial probability distribution for the number of workers who respond yes. Okay, let's go back here and take a look because we've got a pretty big formula here to deal with. The probability of X number of successes is equal to N combination X, P, probability of success to the X power, Q to the N minus X power. And if we write that out as a full formula, we know the combination formula. We're used to seeing N combination R. In our case, we're just using a different variable, X. This is our combination formula right here. Okay? So we need to create a probability distribution, which means it's going to have to show the probabilities of all the possible outcomes of this probability experiment. You're asking 7 people. It's possible none of them will say Social Security. It's possible all 7 of them will say Social Security, and any value in between is also possible. So we're going to need to create a distribution here, and we know that our probability distributions always have an X value, and they're going to have a probability value, but we're not going to just put probability in next. We're going to take that formula. Let's start here by listing our X values. 2, 3, 4, 5, 6, and 7. These are all the possible values that X can take on. Again, it's possible no one will say Social Security is their primary source of income for retirement. It's possible all 7 will say that. So the first thing we're going to need to have in here, I'm going to break this down into 3 parts. When we look at this equation, we have a combination part, we have a probability of success part, and we have a probability of failure part. And I'm going to do a separate column for each one, and then we'll multiply those 3 columns together, and that'll simplify our process a little bit here on how to do this. So we should remember from section 3.4 that Google Sheets will do a combination for us if we start typing equals combination. We need to put in our n value, which is 7, and our x value, but our x value changes. Sometimes it's 0, it's going to be 0, it's going to be 1, it's going to be 2, all the way up to 7. So what we're going to do is we're just going to click on that cell, close our parentheses, and hit enter, and we get 1, and that's the correct answer. Now we're going to drag and drop that down. It's going to do all of those combinations for us very quickly. So we've done the first part of our multiplication here. Next thing we need, the next part is p to the x power. Okay, shouldn't be too bad. Equals p, our probability of success is this 0.28. Raised to the, again, x is in column A. It does the first one for us. We drag it down. Next, our probability of failure. Let's put it in here. Undo that. Q raised to the n minus x. Now, I'll explain a little bit about what these 2 exponents here mean. If you're looking for 3 successes, if you think back to the multiplication rule, you would have to have somewhere in there, you'd have to have 3 successful trials and 4 failure trials. Okay? So if you have 3 successful trials, you're going to have that 0.28 times 0.28 times 0.28. Then you're going to have 4 failing trials, so you're going to have 0.72 times 0.72 times 0.72. So these 2 exponents will always add up to n, your total number of trials, because they represent the number of successful trials and the number of failure trials. So we're very quickly here, equals q 0.72 raised to the parenthesis 7 minus x, and hit enter, and then we'll drag that down. So now we have the 3 parts of our binomial probability equation. We can hop over here and we can say this is going to be our probability of x column. And all we have to do is say equals this number times this number times this number, and hit enter, drag and drop, and we've got all our probabilities there filled in. Now I'm going to go ahead and take this column and that information. I'm going to drop it down to, let's go with, see if I have it in here somewhere. I'm thinking about 4 decimal places. Here we go. Okay. Last thing we should point out, remember, your binomial probability distribution, any probability distribution, all these values have to be between 0 and 1, no negatives, nothing over 1. We already see that. And also, they all have to add up to 1. And there we go. We do see that that does add up to 1. I'll go ahead and highlight that so we know it's not part of our probability distribution. So there we go. We've created this probability distribution, 0.1003, 0.2731. We'll go back and take a look and make sure it looks correct. That was example number 3. 0.10032731. So we see we do have it. Now, after this, they can ask you all kinds of questions. They say, what's the probability of 3 successes? Well, they just look at the probability of 3 successes, and that's your answer. But they also could say things like, what's the probability of up to 3 successes? Well, then you'd have to take the 0, 1, 2, and 3 and add those up. They could say, what's the probability of between 2 and 5 inclusive? And you would take the 2, 3, 4, and 5 and add them up. So there's lots of different ways they could ask you questions on this, but it's pretty simple to answer those questions once you've been able to create this distribution and have all the individual probabilities for all the different values. So that's it today for the video, and take your notes, do the try it yourself problems, and we'll keep going from there. Thank you very much.